about to start. For those who getting problems to find out the notification when I'm going to be live, just follow me on Instagram. I'll post it there all the time. Live now, starting in 2 minutes. How was Spanish, everybody? So I'm just posting this story here. Post a little link to how is this again, web link, Y'all, as you come in, don't forget to do the duties, X off the live chat, press like, and then come back and bring back up the live chat. Let me just finish share this thing here. So believe it or not, I am live. It has been a while, but I am live now. And I intend to be live every day until exams. Story posted. Good day, Keisha, Ren, Aidan, Jaden, Destiny, Zoe, Umtran, Esther, Dr. Beverly just said, everybody, big up on yourself. EDPM was bomb. Anita Baba married. Let me just make this a little smaller one time. I'll look at the questions in the background there. We're about to start in 2 minutes. Alright everybody, those who just come in, press like on the video. Make sure you settle down. I don't know how long this will take. But we're doing things out here. We're doing things out here. Bring up the question now. Waiting for some answers for number 1 and 2. Renice, what's up? What's up? See, you stuff familiar names. I'll hear not that noise in the background because Zion Chavi right around the corner. Right. Let's get some answers for number 1. Make it a little bigger. In an open field, Lucas walks 18 meters towards the south. So in CSEC, this is how they will generally bring, you'll get questions involving triangles like this. You must know your types of triangles that you're supposed to easily identify, your easily identifiable triangles. Easily identifiable triangles. Now this is a must know, triangles. Must know. This is not like a, maybe I should know this. This is a must know. Based on Pythagoras theorem, based on Pythagoras theorem, we have c squared is equal to a squared plus b squared when you have a triangle like this. It'll tell me the must know triangles. CAB 1, 2, 3. 3 triangles. People getting D for number 1. 3 triangles you need to be able to easily identify. You might be hearing some great music and things too. So everybody's saying D for number 1, but I'm not seeing any type of triangles here. 3, 5, 13, 18. It's 5, 13, 18. So sure about that one. Number one type is the 3, 4, 5. And 5, 12, 13. So these two come in most. And you can do multiples of these, right? For example, the triangle can be like a 6. Why is it chat if you know what I'm talking about? A 6, 8, 10 triangle. Like that. can be multiples of it. And the last one is 17 something something, 8, 15, 17, 8, 15, 17. I saw this once, 8, 15, 17. And it helps to know this one time, so you don't need to go and look at no Pythagoras theorem. Remember, you don't have a calculator, so those of you who want to square 13 and thing and fighting up and 13 square as well. Just know these three triangles. So for example, if they give you a missing side, and they say that one side is 3, one side is 4, well, you automatically know that this side is 5. What about in this case? If they give you a triangle in your exam, when is the exam? Monday, and they give you a triangle like 6, 10, what is this missing side here? And it wouldn't be so straightforward. It may be written like the question I have there. What about if you have a triangle like this? And they are saying that this side is 50 and this side is 130. What is this side here? Right? Nice, you've seen some eyes. Yes, you'll get a formula sheet. I'm so tired. Custody. We don't do that. We don't do that here. We don't do that tired thing here. Blessings, Anika. Yeah, 272 people. What you have to do is close the live chat, press like on the video, and then bring back the live chat. When you're doing that, you're helping save the planet. By doing that, it will send out the notifications to more people, and there are more people who want to be here. Alright, so let's see. So yes, this will be 8 because they're looking like 3, 4, 5, right? And you just see now each one multiplying by 2. This one will be 120. Nice. So in the question 1, in an open field, Lucas walks 18 meters towards the south. Lucas walks 18 meters towards the south. And so you're going south, you're going down. Start off here. And then turns and walks 24 meters in an eastern direction. I want to know where he's going. Alright, so you walk 24 meters this way now. 18, 24. And now you walk back, right? He then returned via a straight line to his original position. So I think there's a question loaded in your CSEC exam with this. Is either with a plane or with a ship, something like this, going north, south, something like that. Look out for this question. Types of questions like this when the person make out a triangle and you just need to find hypotenuse. Now you could work out this hypotenuse or you could watch the solution here and see which one really looking like the answer. So 3 by 6 is 18, 4 by 6 is 24, so it's a 3, 4, 5 triangle. 5 by 6, with the answer for the question. I'm missing something here. 18, 24. Oh gosh, when you start to reach big numbers, we get trolls. So 30. So answer that here. 3, 4, 6. We get just for your own answer now, boy. Oh, they're asking for the total distance you walked. Okay. What a way to start. What was the total distance walked in meters? Well, that's interesting. As interesting as in I who created this whole question, right? So the total distance walk would be 30. That's just the warm up. That's just to make sure you're paying attention, man. 30 plus 18 plus 24. So if you want to get these questions to practice, it's on my website now, kerwinspringer.com. You can go and download it. kerwinspringer.com. Look at people saying total distance. So they're asking for the total distance you walk. So total distance. Alright, so 30 plus 18 plus 24. Yeah, boys, that looking like what, 72. So the answer is D. Alright, so I did this question on this channel already. It's like about maybe half of the questions are done already. So we just getting it in order, going through all straight until I get tired and I decide to switch to the advanced live. So maybe I might switch to the advanced live after. Whatever. Which of the following is a representation of Pythagoras' theorem using the triangle below? Oh, there's a 3 marks question. Answer for number 2. 2 is A, right? We already talked about that one. So now I'm going to bring up the next question. Yes, so what lesson we can learn from this immediately is that sometimes you so accustomed with a question, you expecting your own thing, and you didn't read out the whole question and it have an answer there waiting for you. Now in this case, it didn't have an answer waiting for me to say 30, because I so accustomed with this 3, 4, 5 thing, I'm looking for 30. In my own question I make, right, I'm looking for 30. So always read out to the very end of the question. CSEC in maths, they don't normally bring too much new questions, but they're known to change some of the words in a question to make it be a different answer. So make sure you read out the entire question. Using Pythagoras' theorem and the trigonometric ratios, which are the following is the same as sine squared x plus cos squared x. Blessings everybody. Don't forget to close the live chat and press like. Looking for number 3 and 4. Why is it not? Let me watch this too, because this could be suspect. Yeah, they say this one is C, this one is A, this one is B. So C is the hypotenuse, so you're looking for C squared equal A squared plus B squared. I've been paying attention here because I read these questions like about 2 months ago. And next thing the old me tricked the new me. So you're looking, just in case they decided to, put it like this. There is a question in CSEC where they'll straight up asking Pythagoras' theorem. Using Pythagoras' theorem and the trigonometry, which of the following is... Alright, so this is just B. Sine squared x plus cos squared x is equal to 1. This is really hard maths, but CSEC tested this 1 year. So it's in the question bank. The question bank has every recent kind of question that comes to CSEC maths in topic by topic. What is the length of BC in the triangle below? Right, so there's the next simple thing that always comes. Using after, so 2 things they'll test you on, Pythagoras' theorem and how did I get to T? I mentioned that before, so you just come in, so you'll have to watch that part over. Write it down to watch back that part. Nice. So what is the length of BC in the triangle ABC below? From this we see that this is what we really want. The opposite, we don't have anything hypotenuse, so you can remove anything with sine 1 time or cosine. Because sine you need the hypotenuse. They can test you on Pythagoras' theorem or the trigonometric ratio, so sine theta is equal to the opposite over the hypotenuse. Cos theta adjacent over the hypotenuse. Tan theta opposite over the adjacent. So Katua. Which one we thinking of here, boy? Tan, right? Because you have opposite and adjacent, so that's tan. Anytime you see the hypotenuse not given, you're dealing with tan. Or is it this one or that one? Well, we can say that the tan of the angle 50 degrees is equal to the opposite, which is 30, over what we are trying to find, BC. Making BC the subject of the formula, we realize is actually 30 over tan 50. Opposite over adjacent. Opposite over adjacent. 30 over BC. Making BC now the subject of the formula. 30 over. Mendafia answered that question already. You just had to watch back the video for that part. You all just keep on going forward, right? But yeah, oh shucks, but you going on like. Anytime you have a little question, ask it like that. Man, that fed up. How I get it 30? People, how I get it 30? Somebody just explained in the comments to me that somebody said it was 6 by... No. Somebody trying to hack me out. Is that one though? Just now I'll let me bring back up the screen. All kind of thing popping up in the background. I'll let the maths go on, man. CSEC spy, not today, not today. Or these two questions, you all see that? Right, I think you'll see that. Let me get the answer to number 5 and thing. So when next you cut in your bed, I feel, what do you say, boy? I feel tomorrow is a good day, man. Or maybe I should do something meaningful. Yeah, so it's 3, 4, 5 triangle. This man doing maths and talking a whole next language. Waiting for answers for number 5 and 6. Right, so the first maths marathon we did a lot of topics. That's a long marathon. That's about 4 hours. And we do a lot of topics. So today we're going to see how much we can get done. Actually, I want to finish the book today. I want to finish the book today. Yeah, bless her. On my screen and things showing for the whole world to see. CSEC, ease me up. Yeah, we get touch on the advance after. And then we get some answers now. C. I seen people say 5C, 5D. Cain went to sleep on a boat that was sailing at a bearing. A bearings, boy, a bearing of 225. So if it's a bearing of 225, yeah, put your knot and you hit them at 225. Everybody know 225 will 225 going to be somewhere around here, so think about it. They 180, there's 275, 225, 225 will rather be somewhere around this. Alright, okay, the angle through which the boat turn. Hold on, we ain't done it. So you see at 225, so 225, read the whole question, Kerwin. When he woke up, the boat was headed in a northeasterly direction. So northeasterly direction, northeasterly. We're going up the road there. That looking like a straight line to me. Now I can check it for sure. Northeasterly is like 45 degrees this way. If I take away 45 from now, we then end up with 180. So this is at 180 degrees. So this is just a straight line. Alright, let's see. The angle through which the boat turned was, and that's what we aiming for, 180 degrees. That's the entire question there. Bearings question, we're going to test you on something going one direction, then it turn in the next direction and they'll ask you something in relation to that. You must know your cardinal points, what they would signify in terms of bearings. For example, north, south, east, west, northeast. Everybody do here do geography, right? Southwest. Them kind of thing. I don't think they'll give you like the 12 figure south, southwest and them. They're not really into that. But definitely you should know that this would be 45 degrees, this is 90 degrees, this is 180 degrees, this is 275 degrees, sorry, 225 degrees, here would be 275 degrees, that kind of thing. You need to understand your cardinal points in terms of degrees in a circle, in terms of bearings. Why is in the chat if you're good at number 5? Now see the question clearly. Yeah, it's showing up clearly on my screen. There's a U problem they can't see. Number 6. Any answers for number 6? 6A, 6A. If the angle of depression at the top of the pole to the man's head is 50 degrees, and the man's height is h meters, how tall is the pole in meters? So a tie-up, this is probably one of the most tie-up trigonometry questions. I think I posted this on my Instagram already and people are, I'd say more than half the people get it wrong. One of the things people is doing immediately, but this has 50 degrees. But they say the angle of depression. So I tell you that this is actually 50 degrees for real, eh? But this is where the 50 degrees initially went. So if this is 50, that means this had to be 40 degrees. So that is why this is 50 degrees. Angle of depression is equal to angle of elevation. But watch out for this. There's the case where you can tie up yourself and maybe you're supposed to get the angle here and you would put this as a 50 degrees. Let's say the angle of depression at the top of the pole. Angle of depression and angle of elevation is always taken with the horizontal, right? Meaning with a horizontal line. So this can never be like an angle of depression or elevation. So now that we know 40 degrees and the man's height is h, wow, how tall is the pole? Yo, give you a little something else now, man. Oh yeah, this is 8 meters. Okay, cool. So if this is 8 meters, we can bring that up there. So this is like 8 meters here. So we know that this is h, and we're trying to find how tall the pole is, and you realize that they have h plus something. H plus something. What is the plus something that they have? This little piece of the pole here, or maybe big piece or whatever of the pole. So I need to be able to deduce what this length here is. And x, we can find x because once again, this is like, depending on which angle they're using, eh? See, they have 50 or 40. Oh boy. Boy, you want color. Alright, let me try with the 40. Let me try with the 40. Try with the 40 or the 50. Let's try with the 40 first. So if you're using the 40, this will be the opposite. This will be the adjacent. So, tan of 40 would have been equal to the opposite, 8 over the adjacent, x. So x would be equal to 8 over tan 40. You seen any of that there? 8 over tan 40? Yeah. A is the answer. A. Yeah. So these questions are as good as you can get for prediction in terms of what is happening with CXC. What is going to come with CXC? That's all I could say, right? So h plus 8 over tan 40. Now is a good time to say, if you haven't yet checked, go on Instagram and look for @the_student_hub, and the link in the bio of this, click on that, then go into the CSEC Maths channel and you're gonna meet a nice surprise. Anybody on the student hub, press Y in the chat. If you're on the student hub, post that I'm live right now. Although somebody probably beat already. Post that I'm live in the student hub. And it's a Discord channel for the student hub. Next thing is, I will post my verified answers, Kerwin Springer, on my Instagram for like some of the recent years. You know, there people always have these answers. She just started giving out, and a lot of them is be kind of leading you down the wrong path. Like 50 of the questions might be correct, but 10 wrong. Yeah, I give out good thing. So look out for that. Hopefully I can get this up by this evening on my Instagram, so you'll be able to browse through. Look at wise. Look at wise. Alright, so this Student Hub is the place to get your resources if nobody never gave anything in your life before. So go and get things 3D and not struggle. If I had these student help back in my days, shillings. Let's get the answer for number 7 and 8. Yeah, the live will be posted after. My channel is a little too big to go through past papers or things that resemble past papers. Or get the call. In fact, I don't get the call this year. But as a call, that's a good call. Right, from the people, the Illuminati, them, I get call. But if I go through a paper resembling a CSEC paper, right out here, I gotta make my principle and I will go by. Views and likes not adding up. Yeah, organize yourself. And as for number 7 and 8. 7A, in the right angle triangle, show me which trigonometric ratio the sine is equal to 3 over 5. But if I'm using y, it will be cos y. There's no cos y. If I'm using x, it will be sine x because that's the opposite over the hypotenuse. If you don't understand opposite hypotenuse, that kind of thing, man, I have resources for you. I've got the resources for you. Just go and search Cohen Spring and trigonometry. Maths. Don't go and get frightened and look at no art maths and pure maths and thing. In the diagram to the right, PQ is parallel to RT. The value of QSR. QSR is, this is 37, this is also 37. What type of angles are these called, chat? So if this is 37 degrees and this whole thing is 180, and this line is a transversal, that means that I'm looking for him, 8B. Now I'm posting the live on IG. Come on, man. Number 9 and 10. We reach the end. We reach the end, we now start. A dog started thing now. Corresponding. No, alternate angles, yeah, you're correct. Alternate angles. Some people use coin too, yeah? So corresponding would be like here and here. So they'll be the same. Alternate would be like here and here. Dip. That's the answer for 9 and 10. Not real 9. Answer for 9. Remember to circle 7. All you like to see the circles. What I say this was? Sine x to tip of bracket 3. Yeah. The last live last night I didn't go ahead with it, so don't worry. You know, you didn't miss anything. Alright, Vivek, bless up. Now, I noticed when I put CSEC maths, a lot of people from India or Nigeria, I think it's come on and say, yo, this is real easy. This is CSEC maths, this is for Form 5 maths students. So, when I'm doing pure maths, nobody is coming and say that though. It's coming and learn. So anytime you see the word pure maths, if you find this maths is like unbelievably easy for you, come in when we're doing the pure maths, and then you would get your style of maths. Menda need help. Okay, let me just say something very quickly before we go through. 9D, people say 9 is D. 9 is D? Alright, yeah. This is a revision session. This is not take somebody from 0 straight up to get distinction session. Such a session, although a lot of people say I did it for them last year and year before, but generally speaking, such a session is impossible. For me to just come on now and just talk to you and boom, all of a sudden you get a distinction just so. Now there's the thing with memorizing past paper questions if they bring past all past paper questions. There's that. Yeah. So I already give you a little hint something how to get through. There. But what I'm doing here is just refreshing people who maybe not on zero, maybe they are now about 50% man. They're working at something to begin with. So if you find like you're not understanding anything here, it means that you're telling yourself something else. The diagram below represents a house where the roof forms an isosceles triangle. What's the width W of the house? So this is the width here, so I can bring it up here to represent the base of the triangle. This is also 9 because it's isosceles. So I have nothing else. That's all they give me. But if you watch the answers, they're not using any numbers or anything. Well, except here. And you should know, if you're trying to find this missing side, you'll use something called the cosine rule. So if they bring in the cosine rule, this is one way they can bring it. If they bring the cosine rule, this is one way they can bring it. The sine rule, just a quick review. If you have capital A common A, capital B common B, the capital letters for the vertices, the sine rule says like sine of A over A is equal to sine of B over B. Or some people in it as like A over sine capital A, which is the same thing, it's just a ratio of the sides to the sine of the angles, their respective angles. And you could also throw in the next one too, but you always just use this 2 at a time. You all won't get the joy of using this as how someone who is doing paper 2 will get the joy of using the sine rule. The cosine rule is like cos A, C squared is equal to A squared plus B squared minus 2AB cos capital C. Or thinking the answer in the formula sheet will put it like this: A squared is equal to B squared plus C squared minus 2BC cos A. And in this case, you're dealing with the angle here, A, this side A, B, C, common B. This angle is capital A. So the quick way of identifying the cosine rule is when you have an angle sandwiched between two sides. And this is the case here, and you're trying to find the opposite side. The opposite side is the square of the opposite side is going to be equal to, remember what I said, B squared plus C squared minus 2BC cos A. A is like the W in this case, but B and C is the same, so that's why I ended up with 9 squared. And B squared plus C squared is like 2 of the same thing, because B and C is the same thing. So it's an interesting question, one that I should examine and make sure you feel comfortable with. Make sure you feel comfortable with this kind of question. If they bring something like sine or cosine rule, they'll use algebra like this. They wouldn't ask you to like work it out step by step. That's too much maths. They'll just see how good you are at identifying if it's a case that you're supposed to use the sine rule or if it's a case that you're supposed to use the cosine rule. So make sure you can identify the cases like that. Let's get to number 10. Out of 10, how are you feeling? How confident are you feeling for your maths exam? From 1 to 10. So I think I'll go in the student hub maybe right after I finish this live, which I don't know when this could be. This could be like next 2 hours or so I finish this live. I'll go in the student hub and I'll go on the maths channel and I'll probably stay there for half an hour and just any question you'll bring, I'll solve it. But make sure the question ain't looking like you know it from a past paper or anything, because I might delete it. But once you bring a question or any sample question, I will solve it. So there are lots of questions in my inbox right now and I can't answer them. I can't answer all of them. So I just go and do it in a structured way so I can help everybody at the same time. So any question you have, just put it in the student hub CSEC master. And they have brilliant people inside there who just be answering question whole day, every day, just for fun. Which of the triangles are right angle triangles? This is right angle. This is right. We talk about this. We talk about this. What about this one? And what about this one? Is this a 3, 4, 5 triangle? 3, 4, 5. 3 by 4 is that. 4 by 4 is that. Yeah, the multiply right, the same multiple now. And 5 by 4 is that. So, yo, you pass it. What about this? Is this a 3? This one looking a little suspect. This one looking a little suspect. That 10 coming kind of alters the way. 9, 10, 15. No one heard of you, my friend. So you could roll out. 1, 2, 4. D. D. Let me see how these ratings going. 0, 6, 5, 9, 8, 6, 7. We're getting some humble ratings here. A lot of 10s though. We had some 10s in the dance. 6, 7, 7, 7, 7, 7, 8 to 9, 9. So, people who's right, sir, in a, like when you have 100 people in your life, you can write sir. But if it's 460 people and you have a question to ask, you can write sir. Just ask the question. Don't say sir, because by the time I look back, all I gone and I miss. Just ask the question one time now, man. And people is messaging me so too on Instagram. I have so much messages with people saying sir. If I stop, a lot of the other YouTube teachers as well, people is be asking me, how you answer so much messages, thing. I say, right now I'm not answering much messages, I just doing as best as I could. Because if I stop to answer the messages, I'll be robbing the greater good now, boy. So, is hundreds of messages in Instagram just, and every day like our next 100 is pop. If to answer one message would take like around, you answer the one message, let's say 1 minute, then the person will answer back. So let's say one conversation take 5 minutes. Multiply that 5 by 100. 500 minutes. Who have 500 minutes in a day? Plus I doing other stuff. A ship sail 10 kilometers due east from port A to port B before sailing 7 kilometers. Popular. Why is in chat if you ever see a question like this run for CSEC before? Somebody want insight on bases? Didn't I talk about bases already? Why is in the chat if you want me to talk about bases very quickly? There are like no past paper questions on bases because it's a newish topic. Topic came out in 2018 in the new syllabus. In the new syllabus 2018, they say, time to make this train do bases again. So D is the answer. 10 kilometers due east and 7 kilometers due north. Right. Pay attention to this one, eh? Pay attention to this, don't lose no easy marks. So alright, let's start on bases before we do anything else. A little coming on bases. Bases is just a different way to count. Just a different way to count. We learn to count using our 10 digits. So we learn in the decimal system. Decimal here meaning 10. What's I can say about that way? I could say I could do like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But the thing is, the digits are really, it starts from 0, the digits are really 0, 1, 2, 3, 4, 5, 6, 7. These numbers taking forever to write, by 8 and 9. This is the digits, this is the 10 digits. Vibes, right? This is the 10 digits here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And when you want to say 10, you notice we don't have a special numerical symbol for 10. Nobody said, well, like if we use Roman X, right, as it, but we don't. What we do is we combine two of the previous digits, so we like use 10. And this is 11, 12, 13. Counting in other bases, the sim is a similar setup. But you have the amount of digits for the bases. Let me show you what I mean. So this is like base 10, right? So like if I'm counting in base 5, It'll be 1, 2, we'll start off with 0. 0, 1, 2, 3, 4. What's the next number? Anybody in this chat can tell me what the next number is. We come into base 2 afterwards. So 0, 1, and what do you think the next number is there? So what's the next number where base 5? I shall read some comments. Pay the fees, make sure you close the chat, press like. Shout out to everybody from all over the Caribbean and the world. Y means yes for short. So yes, the next number is going to be 10. Or 1, 0 as we should say. 1, 0 in base 5. Because when you're in the base, you can't use that number. So like if you're in base 5, the number 5 will never appear in base 5. So if you're in base 2, the number 2 will never appear. You're just using two digits. When you're in base 10, there's no system, there's no symbol, for 10. So you need to use a combination of the other two numbers to represent 10. When you use this in base 5, this number here actually means 5 in base 5. In base 10, this number here means 10. In base 2, this number here means 2. So 3 will be this. And guess what's happening for 4? We run out of digits to use. It's not like we could say 12. It's not like we could say 21. So you need to start over. Lo and behold, you're on 100 if you was in base 10. But this actually just means 4 in base 2. This could be a little troublesome to understand in the beginning. It's a weird concept. But I'm going to show you how to just bypass the whole concept. But I know some people who like to learn from scratch and understand why it is in. This will benefit you. So 1, 1, 0, 1, 1, 1. So this is like 0, 1, 2, 3, 4, 5, 6, 7, and 8 will come here. And you're noticing now that this was 2 to the power of 1, this is 2 to the power of 2, this is 2 to the power of 3. Little patterns and you can pick up in maths when you're doing bases. It's fun stuff. Real fun stuff. So if you don't understand this, let me just show you what you need to know for CSEC. For CSEC, you need to know how to go from base 2, aka the binary system, to base 10, or maybe even any other base 10, which we call the denary or the decimal system. So let's use decimal. Let's use denary just for kicks. So you need to know how to transport yourself between these two systems. For example, the question I was asked is, was it 2018? I think it was in 2018. Very simple question. Remember, this is just 1 or 2 marks we aim in for any exam that could come on this side. Change 7 into base 2. Chat, what is 7 in base 2? Any one of you saw that question when you're doing your past paper? I know most of you are doing multiple choice practice. But have you checked the paper 2 and see, can you convert 7 to base 2? This was the question I was asked a couple of years ago. So we get 10. I'll come into this now. So let me just do this part first. Ruth, I see a question. Ruth, I'll come to the question. So everybody's saying 111, which is correct. So you need to know how to convert from base 10 to base 2. So how do you do it? It's a very simple method. And this root, this is where I need to pay attention to. Is something that kind of borrows from long division and prime factorization. We put the 7 to relax himself there, and you start dividing by the base you want to convert towards. So this was the denary number that goes there, put him to relax, and you say 2 could go into 7. You ask yourself, how much times can 2 go into 7? 2 could go into 7 3 times, but there's a remainder of 1. How much times can 2 go into 3? 1 time, but there's a remainder again of 1. How much times can 2 go into 1? 0. When you reach 0, you stop, so you lock off. but there's a remainder of 1. And then I read it going up this way. Read the remainders. The remainders are the answer when you're doing it like this. So 1 base 2. That's the answer. Let's do another easy one. Convert 21 to base 2. Convert 21 to base 2. I see there are O's in the chat. I'll be so happy when I see the O's, because I've seen some people saying I'm moving fast. I don't go at a certain speed now. As I say in these live sessions are refresher sessions. If you're looking for from start session, just search in my channel, Cohen Springer bases, and you rock back at your own pace and take out your book, and you can run it, watch it fast, you can watch it slow, you can pull it back, you can think. This is a refresher session, but I'm still trying to teach the whole thing as complete as I can very quickly. Remember, this basis topic I spent on my private class 2 weeks ago. I spent nearly a whole class just going through basis, a whole 2-hour class. I'm going to do this in like 15 minutes here. It's a refresher. It's not like I'm hitting the whole number system. So we get some answers here. 11101. We get a real different answers out here. I'll watch this chat. Watch this chat. It's a mistake that's happening all the time. And if they ask a question like this, they will have all the mistakes in the thing. It's a mistake that's happening all the time. Let me see if they're making the mistake. 21. So we want to go to base 2. So let's start to drop some 2's on that. 2 into 21, 10 times, remainder 1. 2 could go into 10, 5 times, remainder 0. 2 could go into 5, 2 times, remainder 1. 2 could go into 2, 1 time, remainder 0. And 2 could go into 1, 0 times, remainder 1. The answer you read going this way. Once again, this is a symmetrical number. Remember, I always read from bottom going up, right? So 10101 base 2 is the actual answer. What happens is that sometimes people stop here and this one end up popping out here. Yeah, they keep going down all the way to 0. So when you reach 1, say 2 into 1, 0, remainder 1. So it's like, another thing some teachers say is when you reach here, just read it from going like a hook. But I just want to teach you one simple thing. So, why is it chat if you understand that? Oh, that. Well, Anita. So, I'll sort out this dinner, man. So, we did one style of conversion. This can come for CSEC. Another style that can come is that, and the reason I'm spending some time on this topic is because this is one of the only topics you would never see in past papers, especially before 2018, because it wasn't really on the syllabus before. But now it is. Now it is. Base 2 binary, base 10 binary. So let's say we started off in this. And I told you to go from base 2, and I want you to sometimes write a little small cute 2 underneath here to signify base 2. And I told you I want you to transport yourself from this and to give me the decimal version. Root, you understand this method? Once you understand this, you're good to go in here. You don't need to understand the initial part. If you could understand, it's like I'm showing you the formula here. I got it now, understand, nice. How is this coming for CSEC multiple choice? I would say there's a chance of it coming. If I had to say like a percentage, maybe a highest percentage, maybe like 70% chance. But it was higher before. I'd say like maybe nearly 100% chance of basis coming. But what I have seen transpire in these last 2 weeks of exams, imagine in one of the exams in Cape Unit 2, CX is so repeating. They repeat the same question in the same exam. So I don't have much. I wouldn't be like make IT simple and say this exam going to be brand new. There's the chance that you could have a lot of new questions. January had a lot of new questions, but I'm smelling a good bit of repeats coming back again, based on what we see happening. unless they decide to treat that special. And if they do, just make sure you revise from the channel, watch all the videos. Somebody's saying 27, somebody's saying 26, somebody's saying 11 for sure is not 11. Y means yes, we understand. Yeah, that's what Y means. So I'm lost. So you all understood how to go from like 21 into the base, but how do you go from this back into the denary system? Is a longer method but a simpler method. So the number is 1 1 0 1 1, I think. Yeah. Let me say we had this number now. What you want to do is separate that number, space them out a little bit, bro. 1 1 0 1 1. And you're organizing up the powers of the bases. Because this is really 2 to the power of 0, which is 1. 2 to the power of 1, which is 2. 2 to the power of 2, which is 4. 2 to the power of 3, which is 8. 2 to the power of 4, which is 16. Remember, when you put a number to a power, you multiply by itself. So this is like 2 by 2 by 2 by 2, 4 times. 2 by 2 by 2 by 2 is a 2 by 2 by a 2 by 2, a 4 by a 4, which is a 16. So instead of putting those powers, what people do one time when you're accustomed doing this, if you practice this in school, you all did this in school, your teacher do this with you. What people do one time is instead of putting these power numbers here, they will just do this. This is 1s, this is 2s, this is 4s, this is 8, and this is 16. It's just like when you're in the denary system, you have the 1s column, the 10s column, powers of 10s, the 100s column, the 1000s column, the 10,000s column, the 100,000s column, the million column. This is the same column either place value either for base 2. So this is where we convert backwards. We figure out what is the actual value each number here is representing, and we get ready to do some multiplication. Am I doing the correct thing? Yes, I am doing the correct thing. So you multiply these numbers here. So 1 by 1 is 1 every day. 2 by 1 is 2. 4 by 0 is 0. 8 by 1 is 8. 16. What next? What next? Add it up. Yes. Add it up. Add up that soul there, they are looking like 29 to me now. 2 and 16, 2 and 6, 2 and 8 is 10. 27, 27. 27. So this is 27 and base 10, and since it's base 10, you don't need to indicate that because all, 27, just raw. 27. Alright, so that's bases there. You could watch over this, vibe it a little bit, go look up on my channel for more bases if this is... Let's bring up the next question. Back to trigs. Back to trigs. So far what we noticed with trigs, we noticed that you can get Pythagoras theorem, where c squared is equal to a squared plus b squared. We noticed that you need to know the types of triangle, 3, 4, 5, 5, 12, 13, and I always forget the next one. It is something 17, 8, 15, 17, 8, 15, 17. I always know it's 8, 15, 17. Alright, don't forget that again. 8, 15, 17. All multiples of these. So you need to know that. We also see that we need to know so, katoa. We also see that you need to know your bearings. And you should have an idea. You should just know how to identify the sine rule and the cosine rule. So let's continue our adventure in trigs. Give me some answers for this. Yeah, I tell you, my son right there, that's why that was going on in the nursery rhyme in the background, and they're learning nursery rhymes out here. 12b, identify the smallest angular rotation that maps the image of pentagon belonging to itself. Oh, there's this one thing that I think on the syllabus that I spotted. You know, I always say, as a man, I do this long time, 15 years now, I know this entire syllabus back to front to back, know everything, as the boss, greatest of all of them, that kind of thing. But I spotted something recently. They need to know how much, I think I put it in this, how much symmetrical rotation, something with symmetrical rotation. I mean, like I know it, but I never really teach it too much on the channel. Rotational symmetry. I believe, was it that I spotted? So identify the smallest angular rotation that maps the image of the pentagon below to itself. Explain, the people says, it's like if you have this as a rectangle, this as a rectangle, right? And I tell you, what's the smallest angular rotation that it will turn back into a rectangle that facing horizontal like this, like itself again. But if I turn it like this, it doesn't look like how it used to look before. And I turn it 90 degrees. So at the smallest angle that I can turn it so it could get back to itself, 180 degrees. Provided as a perfect rectangle. It gets a little easier when you have this 6-sided figure. How much? Say 1, 2, 3, 5-sided figure. Pentagon. It gets a little easier. How much you need to turn it, and this has to do like rotational symmetry. How much do you need to turn this? How much do you need to turn this so that it will turn back into itself again? So you're thinking of it like, you know, turn it, and come back to itself again. Like if this was a key, if this was a hole, and you had a key, and you put it in and you bring it out, how much you could turn it, how much angles you could, what's the angle you need to turn it to send it back, what's the degree of rotation? And the answer is real simple, 360 divided by the number of sides, right? 1, 2, 3, 4, 5. That'll give you the angle. Well, you're getting for that, boy. Boys. Small kind of weird answers out here, but why people saying 45 degrees? Let me see what my OGs and them saying. If I had to lose it inside here. All you know questions like this get on, right? 12b. This is the problem with this whole exam and memorizing answers. A lot of people memorize off the last 3-4 years of past papers. If they only switch that up on them people, they will be crying in the exam. Not crying, weeping. Weeping is the word to use. People will be weeping in that exam room. So the answer is indeed B. Turn it 72 degrees, it will lock back into itself again. Let me get our next question. Are they trying to revise some of the theory too? I don't just memorize past papers. I mean, in the student, how people will be drilling in all the usual thing that has come. But don't only rely on that. Which of the following letters does not, they do rotational symmetry question, I didn't put it in. So if I put it in here, it can pop. Which of the following letters does not have a line symmetry, but has a rotational symmetry? Back in the days, in my days, I know they used to really ask this question. They used to ask a question like this, with alphabet and thing. Which has a line symmetry, but does not have a rotational symmetry. Always. And then they just stopped. It was like the airbenders, or where's the thing that disappeared? Where's it? And then it disappeared for 1,000 years and then come back. Or the avatar, the avatar. Yeah, this question was like the avatar, it just went and then it could pop. The following letters does not have a line symmetry, but has a rotational symmetry. And everybody is saying D, which is very sweet. I was so happy to see that. because this has a symmetry. You can put the mirror line. Everybody know about mirror line in primary school. You can put the mirror line here, you put the mirror line there. You put a mirror line here, you can actually put a mirror line straight down the center there too. There so, right there so. You could put a mirror line here and here. You can't put one so, but we don't really care. Once you get two already. This one, there's no mirror line that could work on Z. Z just out of timing. So it does not have a line symmetry. All of these have rotational symmetry. Even Z. So Z is the answer. Z has a rotational symmetry. What does that mean? It means like if I started off with Z like this, and I spin it, before I reach back all the way around, I would make a Z again. So this has a degree of rotational symmetry of I forget, 1, 2, something like that. How much images you can get. So I think it's called it 2. The first one and the second one. A degree of the order of the rotational symmetry is 2. So you can get it this way and then you can turn it bling and you get an next Z there, 2. Or you get any sound effects. Javish, don't forget to lock down these people who are see them all the time and things, right? The order of the rotational symmetry in number 14 is best described as, what we have for 14? People saying 14C, 14A, 14C. What we have for 14, right? $14D. So it is everything on it, isn't it? $14A, $14D, $14E. Alright, the order of the rotational symmetry, the number of lines of symmetry in a circle, that out. Rotating an object about the origin until it is symmetrical with itself. This sounding good, but it's not really the order, but they are the right line. So let me see something better than that. The number of times the shape can be rotated about 360 and still look the same. This sounding real sweet. This harmonics, so rock so. The number of symmetrical images a shape can no. A is the best answer. So the number of times a shape can be rotated around 360 and still look the same. Just like with okay. So the order of symmetry of this is 2. Because if I rotate it so it doesn't look the same, but then I turn it this way, bam, it filter picking up and making this thing look weird. This way. So the amount of times I can turn this, it will look the same one more time there, so 2. For the order of rotational symmetry for a circle will be infinite because it will always look the same no matter how you turn it. For a square it will be 4. For a diamond like a square it will be 4, right? Cool, let me get the next question. You spend enough time just watching chat here. 15 and 16, 15 and 16. Oh, this was the other question of rotational symmetry that used to come back in the days. They asked what is the rotational symmetry or a parallelogram? I prepared for things here. I prepared earlier for things. Every time I raise a black on people, they say still flexing. So for a parallelogram, how much times you can turn this thing and it will be the same. this. Ren, Cassie, are you here? Where Ren? Ren already, let me make Ren. Ren is... Oh gosh, I'll stop commenting. I can't even click on Ren. Right. Ren back in the dance. Yeah, garden. So the answer for this is 2. This is just like the rectangle. From the time you turn this 180, it will form back itself again. So 2. The image to the right is best described. Let's get the answer for number 16. The image to the right is best described as... So this is the image here. This is A prime, C prime, B prime. Right? Answers for 16. Hey, Ezekiel, right? Ezekiel, what's up me? And tell me, sir, this is Ezekiel from Marvel, lamppost number, sons. What's up? I am ridiculous, way. Wait. 16a, reflection in the line y equal to x is correct. So this is the line y equal to x, it reflected in that line. You need to understand all your transformation, everything transformation, translation, reflection, enlargement. What I'm doing here is the most likely to come questions, topic by topic, topic by a topic. Which of the following is not needed to specify a rotation? This question can come in other ways, like which of the following is needed to specify a rotation, and they give you a list. Hint, hint. What's the answer for 17? So to specify a rotation in terms of transformation, so you notice we kind of segue off of the trigs into transformation here. To specify a rotation, you need to know the direction of the turn, whether you're going clockwise or anti-clockwise. The center of rotation, yes, you need to know that as well. The origin, nobody care about that when you're trying to refine it. The angle turn, yes. So you need to know the angle turn, the center of rotation, direction of the turn. So which is not needed? C is which is not needed. So C is the answer. I'll just block these people one time or hide user in the channel and whatever. Life must be real boring to just life that boring, man. When I was in school, if I didn't have a live class going on YouTube, I would make up a whole rude name for myself and come and comment a million times just so somebody could block me. That was vibes back in the days. That is vibes for you know. Let me know, that is vibes. New time, that's 2020 is a strange year. Strange year. Make up a rude name. Ha ha ha. Watch people watching the rude name. I'm so edgy. Oh gosh, look at me. Thanks, Javish. I guess I'm answers for 18 and 19 here now. People say all kind of letters there. I see all the letters of the alphabet there. The value of the external angle in a square is 90 degrees. It don't matter, 90 degrees or 90. External and internal angle, the value of internal angle in a hexagon. Common question. That's the internal angle there. The external angle is this guy over here. Let me just give you the one thing to fit this for all. The exterior angle. So for those who like to learn from the root and just know one thing, aka me, you just understand the concept and one simple thing to memorize and you can figure out everything from there. The exterior angles in a regular polygon, must be a regular polygon, eh? You comment not out that time in shape here and say, so the exterior angle in a regular polygon must be equal to 2, yikes, I just now nearly write radians there, boy, in maths, 360 degrees. So the sum, that is the symbol for sum, right? So the sum of the exterior angles in a polygon, in a regular polygon, must be equal to 360. What does that mean? It means that, like if you have the exterior angles here, 1, 2, 3, 4, they must add up to give you 360. So if you have a hexagon is 6 sides. This is your angle here, this is your angle here. You understand what's going to happen here? One time, some people have seen it already. This is your exterior angle, and the interior angle will be the angle 180, take away that. So if I need to find the exterior angle, all of these need to add up to be 360. So since there are 6 of them, one of this angle is very easily found out to be 60 degrees. Just divide by the number of sides. So take 360 and divide by the number of sides. For those who like formula, 360 over n is equal to the exterior angle. So 360 degrees divided by the number of sides will give you the value of the exterior angle. Once you find this, you can find the interior angle by just saying interior is equal to 180 degrees take away the exterior angle. So with the hexagon just now, the value of the internal angle has to be 120 degrees and not 60 degrees because the exterior angle is the 60. But the interior angle is actually an obtuse angle. Stretch out past. Right? You can ask what is an obtuse angle to it. Yeah man, Trishona San. Big up yourself. Let me do our next question. Oh yeah, let me tell you one of the easier questions that is bring for CSEC. Sometimes they would just draw a shape. This is the brain cooler question. They will just draw a shape literally and ask you how to name the shape. Now imagine if you don't know how to name your shapes then. 1, 2, 3, 4, 5, 6, 7. Imagine if you don't know that that's a heptagon and you go on and put something else. So make sure you know all up till, let me say non-gun, non-nagon, non-no-gun, non-nagon, whatever. 9, right? Octagon 8. The transformation below, I'm missing a piece of that question. What is the transformation below best described as? Let's get the answer for 21. What do you think this will most likely be? Would it be a rotation? Would it be an enlargement? Yee! Would it be a reflection? Would it be a translation? 21 is indeed D. It is a translation. If it was a reflection, it would look like this. It would reflect. You know? And one way of seeing reflection is that each point must be the same distance. So that would be a reflection there. If it was a rotation, it would have done this. So it would have actually rotated over with this so that they don't fall over like that. So not that. Obviously an enlargement means getting bigger from a certain point. So enlargements go like this, where it get bigger. Enough talk, time for action. Oh yes, I was never really coming back into this add maths afterwards, boy. Things look a little tired right now, no? So I should just go in the street and have a relax. So how many questions I have? I have one more question in trigs, and then in vectors and matrices I have 14 questions and we're done. So we have 15 more questions. We are number 22. What is the scale factor of enlargement here? In enlargement, okay, this is just, what kind of easy thing is this way? Earlier, I think I talked about this the last time. Enlargement could either come just straight. Wait. Let's see what they say. People saying B. A lot of people saying B, boy. A lot of people are wrong. Time to pose this question on the gram. Give me a second, let me just post this on Instagram. I'll check over this question again. Can you do this? Doing questions like these live now. It getting smaller, yes, so they check it over now. Right, so people realize it's getting smaller, but it's still making a mistake. Just because it's getting smaller don't mean you're going up a -2. So you figured out the trick, when you went in the next direction you put -2. -2 means that it's still getting bigger, it just getting bigger on the next side of life. So it would have, alright, let me explain something. Now you see you have a triangle here. A normal enlargement of scale factor 2. Bam, you expect something like that. Cool? It went from this to this. Object to image. So this was scale factor 2. And CSEC has brought, I think, every single one of this that I'm going to show you. So you just... Now, this is an example where it's going from here to there. Because you see that this is the A, this is the image, the object, and this is the image. So we come into that. Let's go and check the next thing. If I use a scale factor of -2, I will actually end up with the same size like this. I will just end up down here. So a negative scale factor just means it flips in the next direction. It's still enlarging, but it's enlarging in the negative direction. You can divide that, trying to see. So if the scale factor is -2, this is what you expect to see. So what happens if it went from here to there? That's a fractional scale factor. So you're aiming at C. So all those who went down with the C, all those who went down by the C, yeah, you're depending on marks there. You're depending on marks. So what is the level of these questions? CSEC. That's an exam in the Caribbean for Form 5 students. So maybe 15, 16 years. Let me get the last question. Was that the last question? Let's get the... I'm trying to bring up the last question earlier. It coming. Oh, another popular question that CSEC loves. This is their way of like testing congruency. They love to straight up ask you, oh, go on, open up nothing. Right, they love to ask you something like this. Yeah. Now when we finish, I'll be on the student hub and I'll just be answering questions. Black is white on the student hub. Meaning on the student hub Discord channel. If you're on the student hub Discord channel yet, I don't know what to tell you. I'll just go on Instagram at the student hub and click the link in the bio. There's an invite that I have up there that you could just jump in. 50k by next month, so yeah, well, we'll see how the things go. Let's get an answer for 23. And the questions that most people will bring me is popular questions, so I'll be answering those questions. But right now I'm giving you the questions from the question bank, which is questions I devised using my expert decoding skills based on what we have been seeing coming for the last 10 years and topic by topic. So when you finish that, if you want to get this, just go on kerwinspringer.com and download it. You need to use PayPal though. I realize like 1 in every 4 persons have access to a credit card to use PayPal. So there's that. Right? A lot of people got the book already, and everybody who got it had a nice time in the study session. You cannot do so people saying C, B. You cannot determine two triangles are congruent. What does congruent mean? You can't answer the question if you don't know what that means. Imagine if you're in the exam room, what the hell is congruency? I just memorize questions. What is congruency? Congruency meaning the same, right? Same angles. So the 3 corresponding sides are equal in length. Alright, that's something good to me. There are a pair of corresponding sides and an included angle are equal. Pair of corresponding and an equal angle, yeah, them triangles going to end up being the same. This is an actual law in your maths book, eh? There are right angles that have the same hypotenuse and base. That's, yes, a lockdown. Both triangles have the same 3 angles. That's the odd man out. Because you could have the same triangles but be 2 different sides, you know. And then you're not congruent anymore. Congruent, it must be the same angle, same sides. So these triangles have the same angles, but different sides. They're not congruent. These are similar, as the word we use in maths, similar triangles, which can be tested, but they're not congruent. So this is something that comes. Make sure you have this lock and key. We're going into vectors and matrices. Are you ready for vectors and matrices? 14 questions in vectors and matrices. Vectors and matrices is a relatively new topic to the multiple choice scene 2018. So once again, when you're going through, you will see much questions on vectors and matrices, which is why you want to pay attention to what I'm going to do now. So 40 more questions, Hannah. A, the answer was C, eh? I'm sorry. D, the answer was D. Yeah, D. Who say I told her it was D? Garden, big of yourself. floor. As these scholarship hats. When they show these scholarship hats, it means you learn something new. Who come up with that emoticon idea? Was it Make IT Simple? Titi? Was it he who came up with it himself? Matrix multiplication can only occur if the matrices are of the same size. Not true. You could have different size matrix multiplying each other like normal. The determinants of the matrix is not true. Not really say nothing. The number of columns in the first matrix, row by column. So the number of columns in the first matrix must be equal to the number of rows in the second matrix. That is it. The number of rows in the first, this is just a confuser here, in case you didn't revise it properly. So the answer for number 1 is C. A square matrix A multiplied by an identity matrix I is equal to A. Anything multiplied by the identity matrix itself. That's like saying 3 multiplied by 1 is equal to, what the hell, 3. By the way, there are memes in this student have a real kicks. I was watching that last night after I cancelled the live. Woohoo, that's real cracking up. 3 by 1, 3. So, well, it's a square matrix, so it's more like A, B, C, D by the identity matrix. So it should be A, B, C, D. Anything by the identity matrix, you get back itself. So that was the 2 warm-ups. I'm clicking the wrong thing here, boy. 12 more questions to go. How long is live going on for? 1 to 2 minutes. We might finish in 2 hours. That is not a marathon, that is just a mid-distance. Not short. Not short, but it's like a mid-distance. Which of the following matrix does not have an inverse? Matrices. Which of the following matrices does not have a... What do you say in this case? Which is the subject or of the following? I don't care. This is a maths class. Does not have an inverse. So if you don't have an inverse, what is this? What is the condition that will make you not be able to have an inverse? Class. Why wouldn't you have an inverse? So we're doing add maths. I will see. After I do the little student, if I feel to come back on with some add maths, we do that. Maybe I can come back on with some add maths and just go through the whole theory in calculus. Do all differentiation and integration. It was Mr. Charles who come up with that. Sir Charles. That's a big channel in IT to subscribe to. If you're a former student, subscribe to. Even if you're going to do IT in Cape, hit up that channel. CSEC spy in the chat. And run to that different again, B or C. Alright, so the determinant must be equal to 0, and the determinant is AD minus BC when the matrix is of the form ABCD. So the determinant must be equal to 0. So AD minus BC, you can check it in. 4, 6, this will work. This is looking like a 12 scenario. Negative 12, this is looking like he already done. See all the runnings. 1, 0 that good, 0, 1 that good. So these is good. So the answer is B. B does not have an B, the determinant of B is 0, and I can verify it. Negative 3 by 4 is negative 12 minus negative 12 again, because you have negative 2 by negative 6 by 2. You understand? Some people is learning like leading diagonal minus this diagonal. Yeah, and that is 0. So what is the determinant of the identity matrix? 1. 1. You can just look up and check. So 1 by 1 is 1, take away 0, so 1 take away 0 is 1. I have seen something like this. I think I've seen something like this. Come. Anything I have here, make sure you know the theory behind it like that. Anything that you see in this live, learn the theory. This will govern the styles of. One thing is for certain, in this maths exam, you will see some new questions in random topics. So those who memorize and repeat, the max you could get for just memorize and repeat might be like around 50 or 60. So for those who want to do and you don't know like if you're aiming at merit, you should definitely learn everything, like if you're studying for a paper too. No, I didn't hear new Drake freestyle. What is the determinant of the identity matrix I? We already do that one. The transformation matrix that, hey, the people them copyright, let me scratch that off. The transformation matrix represents a, right, so we come into the transformation matrix. We coming into the transformation matrix part. That's correct, Keisha. Sometimes we use the word singular too. Let's talk about transformation matrices now. So this is the identity matrix. So if I have a point 2, 3 and I multiply it by the transformation matrix, you know what? I'm going to get back the point by the identity matrix. I'm going to get back the point. So this is not transforming anything, it's just getting me back the point. Now, all transformation matrices built off of manipulating this. It's like you start off with the original subject and you say this is your maths lab, and you take this and you begin to clone him and you begin to interfere with this, and wild stuff begins to happen. For example, if you put a negative on that, all of a sudden you had 2, 3, and remember this represents a point sitting down here minding his own business. 2, 3, let's say that's the point A, and you wet him down with this transformation matrix T, you know, expertly called T. What's going to happen is that this is going to get negative 2 and 3 here. You can multiply it and verify and see. So your image is actually going to be, so I went in the lab and I drew up a negative sign on the identity matrix. The image, the x value turns negative. So tell me, what does this transformation matrix represent, and where will A situate himself? Where will A, the image of A, situate himself? So for part A, what type of transformation does this do? What type of transformation does B do? If negative was here instead. What type of transformation does C do if I decide to hit him the old swapperoo? If I bring him back into the lab and say, let me just switch them zeros and them ones and see something. Yeah, this is exactly how transformation matrix works. Nobody ever taught me like this, but you get to learn this after a while. The transformation matrix is just like you take the identity matrix and you start working your magical tricks on it, and all of a sudden you can move this letter A all over the place. I'll show you one more style that can come for CSEC just now. So this first one here is actually a reflection in the y-axis. You might say, what? I thought it was the x. It's doing something to the x-coordinate. Yes, it is doing something to the x-coordinate. It is taking this 2 and 3 and making it negative 2, 3, so the A is going to come here. But because you made the x-coordinate negative, you actually reflected it in the y-axis. So this matrix, some people memorize it off. I have about 8 things to memorize off. But if you just understand what it's manipulating, once again, you understand the idea behind it, you can figure it back out for yourself in the exam. This is changing the x-coordinate. It's a reflection in the y-axis. This is changing the y-coordinate. This A would end up down here now, because it will end up with negative 3. So this is like a double prime using this transformation. It's a reflection in the y and the x-axis, this one. Why isn't it chat if you understand what's happening? Yes. Yes. I'm saying yes, but nobody knows who I am saying. Yes to Akid and Anderson. This one over here, actually we can examine this one. So let's do 0, 1, 1, 0. We switch, right? Let's use back the same 2, 3. What's going to happen? Remember, you're multiplying, it'll be like 0 by 2 and 1 by 3 now. So it's going to end up with 3 here and 2 here. It's there, the swappy dappy. So how it's swapped there, this is actually a reflection in what? In the line, y is equal to x. Ooh, exciting stuff. So it's like if you had the 2, 3 here now, 2, 3, it now becomes 2, 3 over there. So your a becomes a prime here. And if you draw the line y is equal to x, wow, that gotta work, yes? On the point, if you draw this line, is actually a reflection in the line y is equal to x. Vibes. Are you keeping up this video? Yeah. All at the very start of the video, I make a mistake with the... I make a mistake with some thing. Total. Remember that? I start off the video on the wrong foot, yes. Frightening people, chair. I haven't seen this like good thing. Yeah, so let's go back to the question now. So this is, okay, that's the question. This represents a reflection in line y equal x. I think I have the questions with the other stuff, so let me just bring them up one time. Because there's one more thing I can show you. You can, remember this is the identity matrix. What about if I do this? If I change the two numbers to like 2 and 2, what does that do to the, what is that? What type of transformation is that going to do to the number? Let your mind consider that for a while there. Oh yes, maths is life. Anytime you're feeling tired, you can just sit down and do some maths and get back energy, yeah? Right? Maths is such a sweet thing, boy. So I don't understand. Seeing 3 people saying they don't understand. We're coming back to it. Let's see my far a little bit, we're coming back. I have 2 more questions. Look at that number 6 here. An enlargement. Well done people, it's an enlargement of scale factor 2. This one. I read enlargement of entanglement. The transformation matrix, and if I throw a negative here, we just talk about this one. We just talk about this one. It's a reflection about the y-axis. Now, there's 2 ways to the maths. There's the way, well, 2 main ways. There's the way where you understand what's happening exactly, like why and the reason, and you understand the root. And there's the way where people just learn to memorize this, and anytime they see this, they know that that is a transformation, a reflection about the y. The second one is the more dangerous method, but like before the exam, some things you would want to learn like that, because for me now to go and teach you over the whole of matrices, the whole of this, the whole of that, understand how to multiply matrix, add matrix, determinant, find the inverse, solve simultaneous equations, go into transformation matrix, it means something happened over the year that you're trying to make happen in the next 3 days. You're trying to make it happen in 3 days. If A is a 2 by 2 matrix and B is equal to 2, by the A inverse, what's the value of 2AB? What? If A is a 2 by 2 matrix and B is equal to 2A inverse, what is the value of 2AB? Anybody understand what the hell they're trying to say in this question? If A is a 2 by 2 matrix and B is equal to 2, okay, I think we need to substitute. Let me examine this question. This question, imagine if you see a question at the end of the exam, you have to read this like 10 times. Alright, so this is really B. This is really B. Yeah, sweet question, sweetness. So 2 by A and B, but they say this is really B. B is really 2 by A inverse. Oh gosh, oh gosh. Whoever make this question is a genius. So 2 by 2 is 4 and A by A inverse. If you multiply the matrix by the inverse, what you think you're going to get? Not 1, you're going to get the identity matrix. So the answer is D. All those who say D, all those who say D, all there is bosses. Bosses. Javish. Like I say, you get lost there, boy. So let me read it over. 2 by 2 matrix. You all are coming back to the transformation because some people, what is that you're making that smelling real good, boy? Alright. I will she cooking something. You know she reheating KFC. When there's KFC getting reheating. Nice man. So there B is equal to 2 by A inverse. So what's the value of 2AB? So you're just going to put 2A and instead of B you're going to write back what they say B was equal to 2A inverse. This 2 by that 2 is 4 and A by A inverse is I. But I feel like I need to double check this on my own time just to make sure, because matrix multiplication is a fishy thing. Yeah? So like if you have 2 by this and this is supposed to happen first and 2 by that and that's supposed to happen first, sometimes it can not work out. Next question. Every time I eating on a live, I remember, I think it was 2018, boy, some woman lost she mind somebody mother. Don't let your mother watch this. Somebody mother so unprofessional eating and teaching these students. This is a YouTube channel, go. Easy. Number 8 and number 9. So we in vectors land here now. We in the vectors land here, people. Alright, so I need to come back to transformation matrix before you roll on. Nightshade, I was trying to remember the whole thing. I remember autonomous, but the sensory meridian response wasn't coming back. And it was response, something response. Autonomous response. Yeah, that's when they eat and mukbang and some people like to hear this. And they just sit down and whole day you just watching somebody from South Korea eating food and just and slurping up noodles and things. I never really catch was the yes, I watch it. But to be honest, I find the Beanie Man one was better. What do you think? I find the Beanie Man and I find the Beanie Man and Bounty was better. Eight C. So 2p is equal to 6. So p is 3, alright, so it had to be one of the first thing. And 3q plus, this is called identical with vectors. So 3q is equal to negative 9 because everything is from negative 1. Negative 8 minus 1, negative 9. 3 by negative 3c. And number 9a, c. C, somebody say A though. Mikhail Morris. Let me see if Mikhail comes through. Vector p is equal to this and vector q is equal to that. Therefore vector 3q, man. Easy thing. Easy thing. 3 by 3, 4 minus 0, negative 3, 9, 12 minus negative 3. So this is the whole trick that they're trying to trick you with here. So 9 and 15, C. Aha. We can't get the fake there, boy. But this will add up, right? Because negative and a negative. Or they don't take no negative sign trick, eh? They will bring them for you, and they will offer them to you, and they will say, do you want a negative sign trick, my friend? And you will say, hell no. And you will collect your marks and go on. Come Monday. Don't take no negative sign tricks. Let me get this. I actually have just like 5 more questions to go. Annabelle. Hey, I remember it all kind of thing I could do here. I want to buy a Tag Boss jersey. It's kind of expensive. But it's very bad. The cotton is very soft. I wish I had it here. I actually made this whole thing last year for some of my private students in my stream. They bought it and think Tag Boss thing. That's when Tag Boss was the greatest. So right now this is a vintage. So if, I don't know, maybe we have some rich viewers here. Feel free to go and jump on that. Cool, when you're showcasing something. I don't know why it's showing up. I'll let them know it's showing up. You can't use calculator in this exam. Ren is saying that 10 is D. What time the live finishing? I should finish before 8 in the next 15 to 20 minutes. The image of Q, and then I'll go on the student hub and I'll be answering any troublesome questions they have. Don't bring no whole paper for me and thing, just bring sample questions. You hear what I'm saying? Nice. Let's start the cycle 3 soldiers. Let me take down this thing. I don't need to buy no shirts, I'm just kidding. The image of this under translation, well, it's a translation, so you just had to add. One of these questions is going to come for the exam and somebody's going to overthink it and just lost marks. So negative 3, 7 is the answer. D. You translate it, so you just add. The image of this under the translation, you translate in, so you just add again. Hold on, let me see. The image of point Q under the translation. So yeah, so just add 12, 0. Oh, yeah boy. Yes. So the image of point this under a translation T, you see this mighty is? Somebody say mighty is. Them small words are mighty words, you know. That is a very mighty word. That's saying that the answer is that in this case they gave us the translation. In this case we were not given the translation. So we're really trying to find this. So if you do the wrong substitution, you end up in a monkey pants. I don't think you have an answer for that, but they may have an answer waiting for you if you do the wrong thing. So we actually trying to find the translation itself. So what translation is needed to send this 6 to 12? Well, I need 6 first, and to send this 1 to 0, I need to take away 1. So the answer is B. All those who are saying B, boy, overthinking is my specialty. So this is a question for CSEC. Somebody calling me from New York. I had to take this one. Hello? You see my number on YouTube, right? Maths classes. Your number saying you're from New York, but you're something Trinidadian. Yes, I'm Trinidad. This is for CSEC Maths now. Yeah, that's the Caribbean Examination Council. How much I charge? 32 US per month. Do I what?
52 US per month?
No, 32 US per month.
33?
32.
32.
Yep, that's right. This is for the CSEC exams. Are you taking the CSEC exams?
No. I have my son. I have the somebody training.
Oh, you're doing it for somebody in Trinidad?
I like good for it. Not really train for it now.
Hear what? Just WhatsApp me.
Okay.
WhatsApp me and we'll work it out. Tell me that was not suspicious call. And that accent something a little not too New York here. And I couldn't really figure out where the accent was from. Alright, so this is that is that. What is the translation? Vector T. Oh God. So I guess somebody really like trying to call me, but hard luck, you know, from New York. So although they found I turn in my phone on airplane mode, so don't try to call me. The image of a point on a translation, what is the translation? I don't say this already, it's B. Let me go forward. So what you need to do is actually subtract. Right? Go and check my videos on translation vectors and I'll let you see. Let me just get the rest of the questions done fast. So I'll go and take a little sleep and then wake up and study some more. Or say that you're going to sleep and sit down with your phone and end up scrolling through Instagram, taking some snapshot, video chat with your persons, and then realize, oh shucks, I need to study now, and then turn into an actual zombie because you had exams today and you didn't sleep and now you need to study and then get paranoid and be prone to anxious attacks and everything. In the parallelogram, M is the midpoint AB, M is the midpoint of AB, MC, expressed in terms of U and V. U going this way and V going this way. Always pay attention to the arrows. They change them every single year. So it's different arrows. Same parallelogram question, different arrow direction. And most of the time it's like this some midpoint today. So instead of going MC, you'll have to go this way and that way, right? So you actually went U, half of it, and you went V, the backwards V, so that's negative V. So what could A? Who said D, boy? One Direction 10th anniversary today. I think it's some live thing showing on YouTube right now. But we have to watch the maths first. We nearly done here, we nearly done. For the One Directioners. Is that popular One Direction song? I don't want to see a song that's not One Direction and get roasted here. Next thing you One Direction people, that's not their song. You don't know you're beautiful or something. That's their song. You pull up a One Direction. One Direction. Wow, what a distracted class. One Direction song. Top song. Oh. You and I. What makes you beautiful? That is the song from back in days. That is the song, that is the One Direction song. Right? For that. So please no. Please no. Let me get the last bit of this maths done. Now I'm seeing some people screaming that they don't understand the vectors. I have videos on vectors. You can sit down and take it in. Sit down and take it in at a slower pace. Get breakdown to you. I have long sessions on vectors as well. I have been real things earlier. Which of the following represents a transformation matrix that is an enlargement of scale factor 2? We come back to this. All you One Direction fans hyper right now, like, yes, yes, you take me back. So that's 10 years ago. So let me see, there was like, so if this was like when you probably have a poster up in your bedroom and you know all of them name and their biography and everything. I don't even know a One Direction name. I must you can identify the name if I see it on Google. Thank you, Arif. Oh. A for number 2, which the following represents not C. Why not C? Because C in the wrong direction. This is how the identity matrix is. So if I do it like C, I will end up flipping it in the y equal x and enlarging it. We don't want all the piece. We just want to enlarge it solely. So we can just use this A. Right? Scale factor 2. Common question. I don't know how much bigger of a hint I would need to write there. Is this an incompatible matrix for matrix multiplication? So this is row by column, right? And row by column, and the number of columns must be equal to the number of rows. So this could work. See this? This could work. So let me start to multiply this. This is looking like a piece of bacchanal. So you multiply this by that and you'll get the first number here. Now remember it's a 2 by 3 multiplying by a 3 by 2. So the answer is going to be a 2 by 2. You're using numbers on the end to figure out what the answer is going to be. So let's get the first number and then that will help guide us. 1 by 3 is 3. 0 by 1 is 0. 2 by 2 is 4. 7. Who have 7? Here 7 and here 7. So what is the differentiating thing here? Both of them is the same thing. Really? Is this the last version of the question bank? I'd make some updates. Anybody who have the question bank can tell me this was the last version of the question bank where both of them is the same thing? Well, must see COD is the answer, right? So C or D is the answer. Matrix multiplication, very easy stuff. go and I actually have a whole video dedicated to matrix multiplication. So what you are supposed to be doing is, as I say the topic, you write down. So okay, I don't know what in the world is matrix multiplication, so I'm going to look up that. I don't know what is matrix transformation, so I'm going to look up that. You can look it up on my channel, you can look it up on Google, you can look it up in your textbook, in your notes, go back over, do that kind of thing. 14 can either be COD. Let me just work out the rest. Let me just work out this one, second row, first column. 0 by 3 is 0, 3 by 1 is 3, and negative 1 by 2 is negative, so it's like 0, 3 plus negative 2. So this will turn out to be 1. So you see that it's working out, and you get be able to work all the other elements. What will happen is that you'll probably be able to eliminate down and figure out which one to work out, so you can figure you can get it through. Alright people, that brings us to the end of the question bank, at least this version of the question bank. This is 200 and something questions between marathon 1 and marathon 3. I put part 2 here, but it should be part 3 now. I'm going to change this to part 3. In part 2 I already did paper 3. I have the paper 3 people. So this is already CSEC Maths Marathon part 3. And love and blessings. You all will see me tomorrow again, for sure. You may even see me tonight. I'm going to take a little break. I might eat, and then in 5-10 minutes I'll be in the student hub for like an hour, going through questions. If you all have it, I'll see if maybe I'll see if I can do any live things on the student hub Discord too. Those who are trying to get into the student hub Discord, at the student hub, go and check this on Instagram, click the link in the bio. Those who want to know when I'm coming on live, go on my Instagram and you'll see I have some marathons surely booked, like Sunday and thing, but like these impromptu lives I will like give notice on the Instagram like 50 minutes before and thing, so if you're on Instagram you'll be able to get notice. Alright, so yeah, we're moving real fast today. Xing them up quick. Yeah, I will let you know for the admats. Feeling like I still have some energy to do some admats. Maybe we could come back later and do the theory for calculus. Because I have stuff on trigs for admats, and I fed up do logs and thing on this channel, and surds and remainder theorem. So we could do some calculus for admats. Sorry to hear that, I see. And with a little one direction, and you don't need man to go through this again, man. Go on. Alright. Which song you all want to hear? Put your request now. Fellas, don't frighten. You can put out your One Direction song too, if you know you have a One Direction song. Oh my gosh. They are going to... I'm not playing no more One Direction song. They go and listen to it on YouTube by themselves. You know why? They're going to copyright strike my video. I walk into that one way. So the $4.6 that I'm going to make on this video go on to One Direction. Thank you, One Direction fans. Yeah, bless up and bless up. I'll get the pump. So do what you're supposed to do. I don't really have anything else to say. If you're a new student watching you from Form 4, I have classes going on now for CSEC Maths and Admaths. And we're looking to get classes in all subject areas that normally get classes. So biology, physics, even pure maths people, I'm looking to try and get any pure maths class for those who want to do pure maths next year. Admaths, POA, Econ, POB, English A and B. So look out for that. Within the next month or so, the Student Hub, which is my online stuff. Everything online I do, the Student Hub will be, yeah, we're gonna get demonetized.